Today, I want to share with you some ideas I had in my mind for a couple of years now about some ways to picture the cosmos in the fields of art and even cinema. It starts with a simple question that you may feel unlogical in the first place, but that will make sense very soon. Question is, what if instead of using a telescope to watch the stars, the nebulas, galaxies, and planets, we use a microscope? And to start answering to this weird question, I prepared for this venue a very simple chemical reaction that I made using inks and solvents, and that I recorded with a camera using a macrophotographic lens that acts almost exactly like a microscope. So let's start it. So I know it doesn't look like stars or nebula, but does it look familiar to you? Is it something you may have seen already in your everyday life? For example, during a walk in the forest, looking at a bare tree over a white sky like this. Looks like almost the same, right? It is actually called a fractal. And fractals are everywhere in nature, if you look at the right place. It appears when a motif reproduces itself at any scale you look at it. So you will have it in snowflakes, for example. As you zoom in its center, the shape stays the same. Same for the blood vessels we have in our vein that looks exactly like rivers networks seen from a satellite. Same for corals that looks like the bare trees we've seen before. And also a lightning strike, if you look at it upside down. It's like a bare tree. And so on with shattered glass that looks like spider web, that looks like snowflake we've seen before. And fractals are so important for me and for my work because I think it reveals something fundamental about the universe. It's autosimilarity. And this principle will be at the basis of my artwork. Voilà. Now I want to show you some images we have from two amazing man-made devices, very expensive, that are orbiting the Earth, but also the Sun, which are, of course, Hubble telescope and James Webb Space Telescope. Thanks to them, we have access to amazing images from the universe, and we are able to analyze and study it very precisely. For example, with James Webb, we are able to look at galaxies that are billion light years away from us at the edge of the observable universe. And with Hubble, we can have access to outstanding nebulas that we have in our own galaxy, the Milky Way. So, of course, those images have always been a very important source of inspiration for me. It is very beautiful. I mean, it's like science fiction. It's so crazy. And I asked myself, what if I could use this principle of autosimilarity to craft my own nebulas, to shape them the way I want, to choose the color, etc. And then I asked myself, what if instead of taking pictures like Hubble and James Webb Telescope do, I could record it with a camera and see them moving in somehow a natural way. Like, for example, this nebula, which is the Crab Nebula, is the result of a very intense explosion we call a supernova, that is the death of a star. And this star exploded in the year 1054 and have been back in time observed by some Chinese astronomers. So could you imagine that these shapes took almost 1,000 years to happen. So to see the actual animation of the explosion, it will take like one picture every year for 1,000 years to see the animation of the explosion. So I wanted to do my own and to see them move. That was my phantasm. And this actual nebula is not taken from Hubble nor James Webb. It has been made by me using inks and solvent in a petri dish that is no taller than this. This is like 3 centimeters wide. And it moves. I can use solvent as an energy to make the pigments move. Also this one and this one that are no taller than a rolling dice. Now I want to bring you to a more familiar place, that is the surface of our sun, our own star. What I'm showing you right now is one of the most accurate animation, stop-motion video actually, that we have from the sun surface. It shows cells of very hot plasma emerging from the core of the star, and each cell you see here is about the size of the Texas state in America. So it's quite huge. And this is me trying to mimic it with my own tiny chemical experiments. And I think it looks quite the same. And the cells you are seeing here are no taller than 1 millimeter, even less. So I thought, to this point, what if I could go further? What if I could picture things that are even bigger and that our telescopes are not even able to picture? So for a long time, I stared at a very cool image that is not an actual photo, but that is like a map of the billion of galaxies we have all around us. We call it Laniakea. And it may be the biggest thing we are able to think about as a human species. And this is amazing. I mean, you have some convergence points with a lot of mass, filaments, and everything is, of course, moving so fast in space. Some people say it looks like our own neuronal network that we have in our brain. And this is me trying to do the same with very simple chemical reaction. So you can see we kind of have the same convergence points here, the filaments, and I think it's fascinating to see it moving and to imagine that maybe it could look like this if we speed up the time of the universe. So I know those examples rather have a romantic value than a real scientific one, but it is actually just for inspiration. It provokes many different results and brings me to even more experimentation. Of course, there is many fails. I mean, I have terabytes of data on my 1,000 hard drives that are full of failure. But sometimes there is a beautiful thing that is emerging that may be considered as a truth about cosmos. Because of course, I'm not doing such many things on them. It's like the nature that is making those patterns. And I think it's beautiful. And it's just for inspiration. So now I want to show you a video I made showing even more example of those similarities between the huge and the very tiny. So this is trying to find the right inks. Fractal again. Crystals. A supernova. Thanks for listening to me.